Hello and welcome back. In today's video, we are going to talk about linear search and binary search. We will also talk about divide and conquer problem solving pattern. So imagine having a list of numbers like this and you are asked to search a given number like 78. So let's jump right in. So our goal is to find a given number or return -1 if the number is not exist in the given list of numbers. So we will begin by linear search. So this is how we can do it. Let's define our function. So our function is going to be search, and then this function is going to accept two parameters, an array and a number to search. So what we are going to do, we are going to loop through the list of numbers or through the array. We use for loop, and then we will begin from 0 because arrays are 0-based index. And then we start from index 0, and then we will go all the way to the end of the array. So we say array.length, and then on each iteration we will add 1. So then inside the loop body, we need to look for the number. Then we will say array of I if is equal to the number we are looking for. So if this is the case, then we are going to return the position where the number we are looking for is. So in this case, we return I. Otherwise, we need to return -1 if the number is not in the list. So we can even shorten this like this. Return index, just like this. So let's run this. We need to call our function search. We will pass two parameters. In this case, it will accept a list of numbers and a number we are looking for. Then we will pass numbers, and then let's say we are looking for 78. Let's run this. We say node, and then search to GS. So now it is returning the number 9. So this is because the number 78 is located at position 9. So let's place the number which is not in this list. Let's suppose we are looking for 106. So in this case, let's run it again. Now you can see it is returning -1. So this is how linear search works. So what is happening here is that this loop will run n times. So meaning that if you have 16 numbers like this, so then this loop is going to run 16 times, and it will need to visit each and every number individually until we hit the target or not. So if you have watched the previous video about the big O notation, then the big O notation on this function is going to be of n time complexity. So if you want to watch the video about the time complexity or the big O notation, then the link is down below in the description. Now here comes an efficient way of searching, I mean binary search. So the way binary search works, so it uses a problem solving pattern called divide and conquer. So divide and conquer is a way of taking a problem and divide it into different pieces. And then what we have to do is to take each and every piece of the problem and solve it again and again until you hit the target or until the entire problem gets solved. So this is how a binary search works. So we are going to do it. So what we are going to do, we are going to define a function such it will also receive similar params, array, and the number we are looking for. Then in this case, we need to use multiple pointers. So we need a pointer which will start from index 0 and the one which will start at the end of the array. So I will call these pointers. One is going to be left, and then the left is going to start at position 0 here at the first number, and then the right pointer is going to start at the end of the array. So this is going to be right is equal to the array, the list of number dot length minus 1. And then what we have to do now, we need to loop through the list of numbers all the way to the end, but in this case by using divide and conquer problem solving pattern. So what you have to keep in mind when you are using binary search, you have to make sure that the list or the array you are dealing with is sorted, otherwise it will not work as expected. So in this case, we'll use a while loop, and then we need to do this until when our left pointer is less or equal to the right pointer. Then what we are going to do, as I said, we'll use a divide and conquer problem solving pattern. So in this case, we need to take our list of numbers and divide it into 2, and then find the middle part or the middle point. In this case, we are going to define a middle point, and this is going to be math.flow, and then we are going to sum the left pointer and the right pointer and then divide it by 2. So we say left plus right and then over 2. So this line of code is going to find us the middle part or the middle point through the list of numbers. And then after having the middle point, we are going to have several conditions depending on what we are looking for or depending on the number we are looking for. If the number we are looking for is less than the value at the middle point, so in this case we say array of middle. So if the value we are looking for is less than the value in the middle, in this case we are going to update our right pointer. So which means our right pointer is going to be middle, the middle point or the middle pointer, then minus 1. We move one step down. So in this case, if it is not a case, now we will check another condition, else if the number or the value we are looking for is greater than the value at the middle point. So in this case we say array of middle, and then what we have to do, it means the number we are looking for is on the other half, or it is on the other part of the array. So in this case we need to shift or take our left pointer one step ahead. So we say left is equal to middle and then plus 1. Otherwise, if none of these two conditions match, it means our values, the value we are looking for and the value in the middle are equal. So in this case we are going to return the position where we find the number we are looking for. In this case we are going to return the middle. Otherwise we are going to return -1 as usual if the number is not yet in the list. So let's run it again. I will say console.log and then search and pass the list of numbers and the number we are looking for. Let's say 78 again. Node and then search.js. So you can see it is returning the same number. So, but in this case, this is way faster than linear search, because this one is going to take the entire list of the array or entire list of the number and then divide it into different parts. So this function through the lens of big O notation, because binary search is way faster than linear search. So this one will use O of log n time complexity. Thank you for watching.